Los Angeles, February 1988. There is a man lying in a hospital bed. He is 69 years old. The kidneys are failing. The doctors have told him this in precise clinical language, because they know by now that he prefers it that way. Not the comfortable version, the accurate one. He asked them about the mechanism, about the timeline, about exactly what would happen to the body, and in what sequence, and at what point consciousness typically begins to recede. The doctors answered as well as they could. He listened carefully. He nodded. A nurse came in, asked if he needed anything. He said, "I'd hate to die twice. It's so boring." The nurse didn't know what to do with that. She left. And I want you to stay with that image for a moment before we go any further. Before the physics, before the war, before the love story, and the disaster, and the philosophy, everything that follows flows from the kind of person who, in that room, at that hour, makes that joke, not for an audience, not to perform courage, but because it was the honest response to the situation. And for this man, honesty was not a virtue he practiced. It was the only mode he had ever really known. His name was Richard Feynman, and he was, without exaggeration, and without the inflation that tends to cloud our view of the recently dead, one of the most honest minds the 20th century produced. There is a place at the southeastern tip of Queens, New York, where the land simply runs out. Far Rockaway, a narrow strip of peninsula where one of the densest, loudest human settlements on Earth dissolves without ceremony into open Atlantic water. On a clear night, facing south, away from the city lights, you can see stars. Not many, not the way you see them in the desert, or high in the mountains where the sky feels close enough to touch, but enough to ask the question that children ask before the world teaches them to feel embarrassed by it. What is all of that? A boy grew up asking that question near that place. He asked it about fireflies. Why do they light up? And how and what exactly is happening inside that small body in the moment before the glow? He asked it about the patterns in ceramic tiles, about the behavior of ants, about the way a spinning plate wobbles when you toss it into the air. He was not asking to be impressive. He was not performing curiosity for an audience. He asked because the alternative, accepting the surface of things without looking underneath, seemed to him not just intellectually unsatisfying, but somehow morally careless, a failure of attention, a failure of respect toward the universe that had, without being asked, arranged itself into something worth examining. His father, Melville, understood this before anyone else did. On walks through the woods near their home, he would stop and name things for the young Richard. Not just the common name, not just the label, but the behavior, the mechanism, the why underneath the what. He would point at the thrush and say, "That bird is called a brown-throated thrush in English. In Portuguese, it has a different name. In Chinese, a different name still." But notice something. When you know all the names, you still don't know anything about the bird. Richard Feynman never forgot that lesson. He spent the rest of his life testing it, pushing past the name of things, into the structure beneath the name, and then pushing past the structure into the deeper structure beneath that, and then acknowledging with what appeared to be genuine delight, rather than frustration, that there was always another layer. Always. Right down to the bottom of reality itself, there was always another layer. In 1948, at a conference in the Pocono Mountains of Pennsylvania, a young physicist stood up and attempted to explain to some of the most brilliant people alive what he had been working on. They did not follow him. This is worth pausing on. The audience included Niels Bohr, who had helped found quantum mechanics. It included Paul Dirac, who had predicted the existence of antimatter from pure mathematics. These were not people who struggled with difficult ideas, and yet what Feynman was saying refused to organize itself into their existing frameworks. It was not that his mathematics was wrong, it was that his mathematics was arriving from a direction no one had thought to look. His insight, and this is one of those moments in the history of science, where the word insight feels inadequate, where you need a word that also contains the idea of a door opening into a room that shouldn't have been there. His insight was this: when a particle moves from point A to point B, it does not take one path. It does not take the most efficient path, or the fastest path, or the path you would intuitively predict. It takes, in a precise mathematical sense, every possible path simultaneously. It takes paths that loop backward through time. It takes paths that travel to the far edge of the galaxy and return. It takes every conceivable road through the geometry of the universe, and the actual behavior you observe is the result of all those paths interfering with each other, some reinforcing, some cancelling, until what survives is the sum of all possible histories. Write that again. The universe is not choosing the single correct path. The universe is exploring every path. And the world you observe is the result of that total exploration filtered through interference and probability into what appears at your scale of perception to be ordinary, predictable, single-event reality. Think about what that means for a moment, not for physics, for everything. The model of reality, in which there is one trajectory, one correct answer, one road that leads from cause to effect in a clean, unbroken line. That model is not how the universe actually operates at its foundations. The universe at the quantum level is inherently, structurally plural. It considers options. It weighs them. It produces outcomes that are, in principle, only ever probabilistic. Feynman did not draw grand philosophical conclusions from this. He was suspicious of people who did. But he also never stopped noticing, with a kind of quiet amusement, that the universe at its deepest level behaved in ways that should have surprised us more than they did. We had decided somewhere in our cultural history that nature was mechanical, that it ran like clockwork, that the future in principle was determined. And then we looked more carefully, and it wasn't. Before we go further into the physics, you need to know about Arlene. Arlene Greenbaum was Feynman's first wife. He had known her since high school. She was, by the accounts of everyone who knew them both, the person who most fully understood what he was. Not the reputation, not the mathematics, but the actual person underneath all of it. She was also dying of tuberculosis when they married in 1942. A death sentence in gradual installments. Feynman married her knowing this. His parents objected. He ignored them. He worked on the Manhattan Project at Los Alamos while she was in a hospital in Albuquerque, 2 hours south. He drove to see her on borrowed jeeps whenever he could. He wrote her letters constantly, sometimes serious, sometimes absurd, sometimes both in the same sentence. On June 16, 1945, Arlene Feynman died. She was 25 years old. 3 weeks later, on July 16, 1945, at a site in the New Mexico desert called Trinity, the first nuclear weapon was detonated. The project Feynman had poured himself into, the project that had been, in part, his way of staying in motion while the person he loved was dying, produced a light brighter than the sun, visible for 200 miles, and the shock wave that arrived at the observation post as a sound no one had any existing category for. The other scientists celebrated. Some of them wept with relief. Feynman drove back to his quarters alone. He wrote later that he found himself sitting in a restaurant in New York City, watching a man fix a radio, and he realized he could not think, could not follow the logic of the repair. He had calculated the critical masses of uranium and plutonium. He had solved problems that graduate students spent years on, and now he was sitting in a diner, watching a man fix a radio, and he could not think. He understood that he was, as far as he knew, the only person who had done the full arithmetic, who had calculated precisely what the bomb would do to a city. And he had then reported it, and continued working, and kept going. He was 27 years old. His wife was dead. He had helped build a weapon capable of ending civilization. And he was sitting in a diner in New York City with the full weight of both of those facts pressing down on him from opposite directions. This is the part of Feynman that the mythology tends to move past quickly. The version that circulates most freely is the one who played bongo drums and cracked safes and performed his own irreverence for anyone who would watch. That version is real, but it exists downstream of this moment. The lightness came later. It was constructed later. It was, in the specific clinical sense of the word, adaptive. He rebuilt himself around curiosity, because he had seen what happened when intelligence was not tempered by humility, when technical capability outran moral imagination, when the people who understood how a thing worked were not the same people as the people who decided whether to use it. He never made a career of warning. He was not that kind of man. But he never forgot either. January 28. 73 seconds after liftoff, the Space Shuttle Challenger broke apart over the Atlantic Ocean. All 7 crew members were killed. The nation watched it happen on live television, a slow, unfolding divergence of white smoke trails against the clear Florida sky. The kind of image that embeds itself in memory and stays there permanently, because the mind cannot reconcile what it is seeing with what it expected to see. Feynman was asked to join the Presidential Commission investigating the disaster. He was 67 years old and already ill with the cancer that would eventually end him. He agreed anyway. At a commission hearing, he produced a small piece of O-ring material, the rubber seal from the shuttle's solid rocket booster that had failed in the cold temperatures of that January morning, and dropped it into a glass of ice water. He held it there for a few seconds. He removed it. He demonstrated simply and visibly that the material lost its resilience when cold, that it did not spring back, that a seal made of this material, in temperatures like those on the morning of the launch, would not seal. The engineering teams had known this. Some of them had tried to stop the launch. The information had traveled up through the management chain and been overridden, not because anyone believed the risk was zero, but because the decision had been framed in a way that put the burden of proof on the engineers who were worried, rather than on the managers who wanted to proceed. The question had become, can you prove it will fail, rather than, can you prove it will succeed? This is a mistake so old, it does not have a name. It is older than NASA. It is older than engineering. It is the mistake of reversing the burden of proof in a system where the consequences of being wrong are not recoverable.
Feynman put it plainly in his appendix to the Commission's final report, an appendix the Commission initially tried to suppress, and which he insisted be included.
For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. Nature cannot be fooled. 4 words. The entire history of human institutional failure compressed into 4 words. Every bridge that collapsed because the reports were optimistic. Every drug that reached market because the trials were inconvenient. Every warning filtered out at the level of management before it reached the level of decision. You can fool the Commission. You can fool the press release. You can fool the quarterly report and the public statement and the internal review conducted by the same organization being reviewed. The physical universe does not participate in any of that. It does not care about the political pressure on the launch window. It does not adjust its behavior based on what you need it to be true. This was not, for Feynman, a political statement. It was a description of reality. But it was also, if you were paying attention, one of the most political things anyone said in that entire decade. There is an interview filmed in 1981, part of a BBC series, in which Feynman is asked whether his scientific understanding diminishes his experience of beauty. The interviewer expects a particular kind of answer. The answer scientists often give when they want to seem like full human beings. Yes, of course, I can appreciate the flower and also know the biology. A polite reconciliation of 2 modes. Feynman does not give that answer. He says that he sees a flower and he sees beauty in it, the way an artist sees beauty in it. But he also sees the cells. He sees the complicated interactions inside the cells. He sees the fact that the colors of the flower evolved over millions of years, driven entirely by which wavelengths of reflected light caused which insects to land and pollinate and continue the line. And he asks, does knowing that diminish the beauty, or does it add dimensions to it? Does the beauty become less, or does it become deeper? He is not asking rhetorically. He is genuinely curious whether the person across from him has thought about it that way before. This is what made Feynman unusual, in a way that is difficult to fully describe without making it sound like praise. It is more accurate and more interesting than praise. He did not experience the explanatory power of science as a reduction of experience. He experienced it as a multiplication of experience. The more precisely you understood how something worked, the more surface area the thing had, the more places it connected to other things, the more questions it generated. Most people move toward answers because answers feel like resolution. The question is uncomfortable. The answer restores comfort. The inquiry ends. Feynman moved toward answers and found more questions. Every time, without apparent frustration and without apparent fatigue, the inquiry did not end, it branched. And he followed the branches with the same attentiveness he had brought to the fireflies in Far Rockaway 60 years before. He called this the discovery that the world is more complicated than you thought, the confrontation with a fact that does not fit. He called this the pleasure of finding things out, not the having found them out, the finding, the active present tense of it, the motion, not the destination. We talk about the pursuit of knowledge, as if knowledge is the goal. But for Feynman, the pursuit was the goal. The knowledge was just what you passed through on your way to the next question. We return to that hospital room in Los Angeles. February 9th. Feynman had been given the opportunity, as some dying people are, to make statements, summations. The kind of thing that eventually gets carved into stone or printed on the photographs or repeated at memorial services by people who knew him and by people who only knew of him. He was not constitutionally a man for summations. He had spent his career resisting the pressure to say more than he knew, to gesture toward grand unified theories of everything, when the actual state of the evidence was messier and more honest than that. He believed, with a conviction that was both intellectual and moral, that it was better to say, "I don't know," than to fill the silence with something confident and empty. He said, near the end, "I think it's much more interesting to live not knowing than to have answers which might be wrong." And then he said something that has the quality of a statement that seems simple on the surface, and then, if you leave it alone for a while, grows a kind of root system you did not expect. He said he was not afraid of death because he had already been dead before for the billions of years before he was born, and had not found it inconvenient. Think about what is inside that observation. For approximately 13.8 billion years, the atoms that would eventually constitute Richard Feynman traveled through the universe without being Richard Feynman. They were hydrogen in the early cosmos. They were the core material of first-generation stars. They were synthesized into heavier elements inside those stars as the stars fused and burned and eventually collapsed and distributed their contents across the galaxy in the violence of supernovae. They were dust, they were gas, they drifted in formations across distances that make the word distance feel insufficient. And then, by a process we understand only partially, they became organized into a pattern complex enough to ask questions about itself. Not just to exist, to ask why it existed, to look at the firefly and want to know the chemistry, to look at the spinning plate and calculate the ratio, to sit in a hospital bed and make a joke about the tedium of dying because performing fear for this particular arrangement of atoms would have been false to the way things actually were. The atoms did not care in any of those 13.8 billion years about the questions. The asking was new. The asking was Richard Feynman. And it is, with some variation, you sitting somewhere, turning these ideas over in whatever private darkness you carry your thinking in. The asking is what the universe does when it becomes organized enough to look at itself. And it does not do it often, and it does not do it for long. The photograph taken by Voyager 1 in February 1990, the one that shows Earth as a fraction of a pixel in a beam of scattered sunlight, was taken at the request of someone who had spent years trying to communicate something specific about the relationship between scale and responsibility, about what it means to know how small you are and to act accordingly. Two men, one working from inside the atom, one working from outside the planet, together. Without coordinating it, without intending to produce a unified message, they produced one. It goes something like this. You are here because of 13.8 billion years of physics. You are here because of stellar nucleosynthesis and planetary formation and the emergence of self-replicating chemistry and 4 billion years of biological evolution. You are here because of every ancestor who survived long enough to reproduce in every environment hostile enough to make survival non-trivial, all the way back to the first molecule that could make a copy of itself in the warm chemistry of an early ocean. You are, in the most precise physical sense available to us, the universe become aware of itself. And you are doing this particular configuration of awareness, this specific combination of curiosity and memory and the capacity to ask why for a very short time, on a surface that is from outside invisible, a fraction of a pixel, a mote of dust in a sunbeam. What Feynman would ask, what he did ask in different forms across an entire lifetime, is whether you are using the time honestly, not productively in the economic sense. Honestly, are you looking at the thing as it actually is, or as you need it to be? Are you willing to find out that you were wrong, and then use that wrongness as the starting point for a better understanding? Are you willing to say in your work, in your judgments, in your understanding of the world around you, I don't know? Because that willingness is the rarest thing the universe has yet managed to produce. More rare than the formation of planets, more rare than the emergence of life. The willingness to be genuinely uncertain and to find that uncertainty not threatening but interesting, to love not knowing, is so unusual in the full senses of known matter that it may only exist here, on this point, in this sunbeam, for this short time. He said it in a hospital room in Los Angeles in February 1988, a few days before the kidneys stopped and the configuration dissolved. I think it's much more interesting to live not knowing than to have answers which might be wrong. The atoms are still out there. They are not Richard Feynman anymore. But for a while, for the specific, irreplaceable, unrepeatable duration of one human life, they were curious. That is not nothing. That is in fact everything we have.